All right, Algebra 2. This is the last test, 16A. So let's get through this together.
Flack math! Give me some math and I'll give you some flack. Flack math!
All right, number 1. Here we go. Use the discriminant to describe the roots of the equation. All right, so first we have to write it in standard form. Then figure out what our A, B, and C are. Okay, so all I'm gonna do is get this guy over here. So here's my standard form, 9x squared minus 12x plus 4 equals 0. So what's our A, B, and C? A is the coefficient of the x squared term, B is the coefficient of the x term, and C is our constant. Okay, so now we're gonna plug it into our discriminant, which is b squared minus 4ac. All right, b squared is negative 12 squared minus 4 times a, which is 9, and then c is 4. So this is going to be positive 144 minus 16 times 9, which is 144. All right, that gives us 0. So remember, when you get a 0 as your discriminant, that means you have one real solution. Okay? If you get a negative as your discriminant, you get two complex solutions. So you have imaginary numbers as part of your solutions. If you get a positive number, then you have two rational solutions, or real numbers, okay? So there is one root, one, and then we're gonna say one real root, okay? Number 2, use long division to divide. All right, let's do it. So let's set it up. So this guy goes on the outside, so it's x squared minus 2x plus 5, all divided into this big old sucker, 3x to the 4th plus 2x cubed minus 3x. Oop, we've got to put in our placeholder, so we need a plus 0x squared minus 3x plus 9. All right, steps to long division. First step, dirty. Monkey smelled bad, so D, divide. So all you're doing is dividing that first term. So 3x to the 4th divided by x squared is just 3x squared. So all you're doing is taking an x squared away from there, so you're really just subtracting 2 exponents every time you do this step. Okay? So 3x squared times, now you're multiplying. 30 monkeys, so multiply it. So you get 3x to the 4th, you're just distributing. 3x squared times negative 2x is negative 6x cubed. 3x squared times 5 is positive 15x squared. Now you're gonna subtract. All right, what happens when you subtract? These cancel, and then you're gonna chicken scratch all of this stuff. So you're chicken scratching all of that. Boom, boom, okay? Because you're subtracting all this trinomial. So now we don't have to subtract, now we're adding. So this is 8x cubed minus 15x squared. Next step, bring down the next term, which is negative 3x. All right, start over. Divide again. You're just dividing an x squared out of x cubed, so you're left with a positive 8x. Now multiply, distribute everything. 8x cubed minus 16x squared plus 40x. Now you're gonna subtract this whole thing. So chicken scratch, bok, 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 bok. All right, then you get a negative 15x squared plus a positive 16x squared, so you just get x squared. This adds up to negative 43x. Bring down your last term and start it again. All right, you're just taking an x squared away from x squared. You get a 1. All right, now multiply. Well, that's easy. You're just multiplying 1 times that whole thing. X squared minus 2x plus 5. Now we're gonna subtract. Okay, chicken scratch, bok, 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 bok. And you're left with negative 41x plus 4. Okay. So you have nothing else to bring down, so this is your remainder. Where does that remainder go? Right up on top here, plus negative 41x plus 4 all over x squared minus 2x plus 5. Okay, awesome. It looks messy, but it's right. Good job. Okay, number 3, find the roots of the equation. Okay, so the roots are basically what x's will make this 0. Okay, so if you were to graph this, it would be wherever this graph crosses the x-axis. Okay, because where y is 0, what x's will make y equal to 0? Well, where they cross the y-axis. Okay, so let's factor this. This is just what two numbers multiply to get positive 4, but add to get negative 4, negative 2, and negative 2. Okay, so what are our roots? Our roots are just 2, and then remember we have a multiplicity of 2 because there's 2 instances of your solution being 2. Okay, well, what's this graph gonna look like? Well, let's graph it. We could pick some values here, but really this looks like this: y equals x minus 2 squared. Well, this is a horizontal shift. Remember the horizontal shift? It's the opposite of that, so this parabola gets shifted over here. So this guy looks like this. So that's what that graph looks like. That's pretty cool. All right, so now we're gonna describe the relationship between the roots, the zeros and the x-intercepts, okay? These are all the same thing. The roots are where the graph intercepts the x-axis, so the x-intercepts, and it's also the zeros, okay? So this is all the same terminology for the same concept, okay? So you have a multiplicity of 2, so this is x equals 2. That's your x-intercept, your only x-intercept, and it's your only 0. It's the only thing that makes that equation true. It's the only thing where y equals 0, okay? So that's it for number 3. Okay, number 4, we're gonna solve this system of equations. So this is 3 equations with 3 variables, which means it's probably solvable. So we can only solve for 3 variables if we have 3 equations. All right, so let's try this. So we've got 3 different equations. So I'm gonna just label these equations. This is equation 1, this is equation 2, and this is equation 3. And that way it'll kind of help us figure some stuff out here. You can solve this by substitution, elimination, or a combination of the two if you wanted to. All right, so look what happens. If I just add equations 1 and 2 together, what's gonna happen? The x's are gonna cancel. So I'm gonna start with that. So I'm gonna add 1 and 2 together. So what happens when I do that? I get this equation. So if I add those together, I get 4y because the x's cancel. So y and 3y is 4y. Z and z is 2z. And then 9 and 5 is 14. All right, well, that was pretty cool. So that's one equation with 2 variables in it. Now I just need one more equation with 2 variables in it and I can solve. But it has to be y and z. So what's another way to eliminate x? Well, let's see. If I do some manipulation here, if I multiply this by 3, and then I multiply this guy by 2, what's gonna happen? Well, I'm gonna end up with a negative 6x and a positive 6x, and when I add those together, they'll cancel. So let's try that. So this gives me a negative 6x plus 9y plus 3z equals 15. And then this guy gives me a positive 6x minus 2y plus 4z equals 20. So now when I add these together, those cancel, and I get 7y plus 7z equals 35. All right, so now I've got 2 equations with 2 variables in it. So I'm just gonna bring this down here so it's close and friendly. Okay, so this isn't great, but I could still use elimination to figure out. So I could get rid of z, or I could get rid of y. Z's got smaller numbers, so I'm gonna get rid of z. If I make this a positive 14 and this a negative 14, that would work. So let's do that. I'm gonna multiply this guy by 2, and then I'm gonna multiply this guy by a -7. And that'll give me what I want. All right, so let's multiply this by 2. I'm gonna just write it over here. So 14y plus 14z equals 70. And then my next equation, -28y plus -14z equals -98. All right, add them together, and I get -14y equals -28. So what's y equal? +2. So because when you divide by -14, you get y equals 2. All right, now you just kind of have to climb back up into these other equations to figure out the rest. So since we have y, now we can figure out what z is. Let's plug y into this equation. That looks pretty simple. So 4 times y, which is 2, plus 2z equals 14. So 2z, subtract 8 from both sides, equals 6. So z equals 3. Now I have 2 out of the 3 variables. All right, let's plug both of these guys into this top equation. So that's going to be 2x plus y, which is 2. So I'm taking this guy and I'm plugging it in right there. Plus z, which is 3, equals 9. So 2x plus 5 equals 9. 2x equals 4. X equals 2. All right, so we know it works in that top equation. Let's test it in this middle equation. So -2 times x. Well, x is 2, so that's -4. Let's just do that. So that's -4 plus, all right, y is 2. So 3 times 2 is 6. And z is 3. It equals 5. That works there. Let's check it in here. So 3 times 2 is 6 minus y, which is 2, plus 2 times 3, which is 6. 6 minus 2 is 4, plus 6 is 10. That works. It works in all 3 equations. So here's our answer. X. Put the x first because that's alphabetical, and we like alphabetical. 2. Y is 2 and z is 3. Now you could have done substitution. You could have used this in substitution here and gotten z by itself and got z by itself here, and you could have done some stuff with that. Elimination is not the only solution, so if you want to do substitution, you're welcome to do that. Okay, number 5. How beautiful is this? It's just a difference of 2 squares. How do you factor a difference of 2 squares? Square root of the first plus the square root of the second times the square root of the first minus the square root of the second. That's it. So nice. Thank you, number 5. All right, we're gonna solve this radical equation. So first step to solving radical equations is to get the radical by itself. So how do we do that? We have to get rid of 4 from both sides. So our new equation is square root of 8x plus 3 equals 2. Now what do? Now we have to square both sides. That's the second step to solving radical equations. So we're going to square both sides. So that square cancels that radical, so we're left with 8x plus 3 equals 4. Now we just solve this normally, just following our steps to solving equations. So get rid of that constant first. So 8x equals 1. Now divide both sides by the variable's coefficient. So divide by 8. So x equals 1/8. All right, now we're going to test this to make sure it works, because sometimes it doesn't. 8 times 1/8 is just 1, plus 3 is 4. Square root of 4 is 2, plus 4 is 6. It checks. Boom. Good job. All right, number 7. Let's solve this quadratic equation. We can actually just do this. We could solve it by factoring, or we could just try to get that x by itself. And since there's only an x squared, we could do that. So let's divide both sides by 4 first. So x squared equals 81. Now square root both sides. X equals positive or negative 9. Don't forget, when you square root something, you need the positive and the negative version of it. Good job. Okay, this is just solving an equation with fractional exponents, okay? So remember, the top number is the power and the bottom number is the root. So we could cube both sides and then fifth root both sides. Basically what we're doing is we want to cancel out that exponent. So we're going to take both sides to the 3/5, okay? That will cancel this and you're left with x. But now we have to determine what is 32 to the 3/5. Well, remember that 3 is the power and that 5 is the root. Whenever possible, it doesn't matter what order you do this in, you could take 32 to the 3rd power. That's going to give you a big number. But you can take the 5th root of 32. What's the 5th root of 32? That's 2. And then to the 3rd power, that's 8. Wow, that was a lot easier than trying to take 32 to the 3rd power. But you can do that if you want. If you have spare time, that's cool, whatever. Okay, number 9 is probability. Oh, I like probability. So remember, when you're looking for probability, you're looking for number of favored outcomes. In this case, it's however many numbers that are in between 1 and 50 that are multiples of 15 over the total number of outcomes. Okay? So in this case, probability multiple of 15. Well, how many multiples of 15 are in between 1 and 50? Well, there's 15, 30, and 45. So there's 3 out of how many numbers? 50. That's it. Okay. So you can either write it as a fraction or you can write it as a decimal, which is 0.06. Okay, number 10. This will be the last one we do today, and we'll do 11 through 20 on Thursday. Okay? So find b, round to the nearest tenth. So we're going to use this law of cosines, which the real question would have been just to say, find b, figure it out. What are you going to use? The law of sines, law of cosines, whatever. But number 10, it gives it to us. Thank you, whatever. So all we're doing is plugging stuff in and figuring it out, okay? So b squared, that's what we're looking for. So b squared equals a squared. Well, what's a? Whatever's opposite of angle A. Remember, that's 9, so that's 9 squared. What's opposite of C? 8. So 8 squared minus 2 times 9 times 8 times the cosine of what's B? 38. Okay, we can do all this. That's pretty awesome. So that's B squared equals 81 plus 64 minus 144 times the cosine of 38. So I'm not gonna write out the cosine of 38 because it's gonna be a long decimal. So we're just gonna keep it in the calculator and do all those calculations. So let's get as far as we can before we have to find the cosine of 38. Okay, so b squared equals 145 minus 144 times the cosine of 38. Okay, let's whip out the calculator. Cosine of 38, so 38 cosine times 144. Okay, so now I'm gonna do something crazy. I'm gonna do the subtraction backwards. So I'm gonna subtract 145 and then I'm just gonna negate my answer. So this is the same thing as saying 145 minus all that. So instead of negative 31.53, I'm gonna say positive 31.53. 31.53. Okay, so now I'm gonna square root it to give me approximately 5.62-ish. And it says round to the nearest tenth, I guess. So we're gonna say B is approximately 5.6. Okay, so when you're asked to round to the nearest tenth, it's always good to do all your calculations at least one more decimal place or two more decimal places, just so you have a more exact answer. And then you can round at the very last step. Okay, that's number 10. So we'll do 11 through 20 next time, so stick with me. We'll finish this together. Good job.
Flack math! Give me some math and I'll give you some flack.